October 2025. Something changes inside 3I Atlas, not gradually, not the way a comet slowly brightens as it falls toward the sun. This is a switch being flipped, a sudden surge in energy output, a restructuring of its coma, and a series of movements that no natural object has any business making. The data comes in from independent observatories across 3 continents. It is cross-checked, rechecked, and quietly confirmed. Something inside Atlas is activated. The agencies say nothing, the forums go into overdrive, and a small circle of astronomers begins asking the question nobody in an official position will touch. What exactly just turned on inside 3I Atlas, and what is it preparing to do? Atlas entered the picture before most people were paying attention. It arrived from the direction of Sagittarius on a trajectory that didn't belong to anything in our solar system. The hyperbolic excess velocity, the speed it carried beyond what the sun's gravity could account for, was too high for a local object. The interstellar classification came fast. This was not a comet from the Oort cloud or the Kuiper belt. It came from somewhere else entirely. That alone should have made it the most scrutinized object in the sky. Instead, the official reaction was measured, cautious, almost deliberately flat. Routine interstellar visitor. Interesting. Under observation. Move along. But the data kept arriving, and the data kept refusing to behave. The first red flag was chemical. Early spectroscopic readings from the Atlas Spec Lab group flagged an elemental composition that ran counter to everything on the established comet database. The dominant signature was nickel, not the iron-nickel blend that naturally occurring comets consistently show when their volatiles burn off in the solar heat. Pure nickel, almost clean, with iron registering at near zero. That single result triggered an immediate calibration review. The assumption among senior researchers was instrument error. The numbers were simply too clean, too selective to be natural. But the rechecks came back identical. Independent observatories using different equipment on different nights confirmed the same anomalous nickel signature. The calibration defense collapsed. What remained was the data itself, and the data pointed to a body whose surface composition had been refined. Then came the gas. Standard comets outgas primarily water vapor. As solar heat sublimates their icy interiors, the ratio is predictable, well-documented, and essentially universal among known comets across decades of observation. Atlas broke the ratio entirely. Its coma was dominated by carbon dioxide at concentrations 5 times higher than water, the 3-micron CO2 line saturated every spectrograph pointed at it, while water vapor barely cleared the background noise. On its own, elevated CO2 can still fall within the range of a cold origin comet, one that formed in the deep outer system, where temperatures suppress water ice. Researchers willing to stretch the models could find a natural explanation, and many did. But that explanation was already under strain before October arrived. What happened in October could not be stretched into any existing model. The activation event began with a photometric anomaly detected simultaneously by the Ibero Tracker Collective's distributed sensor network and Bill Gray's open-source orbit calculation team. Atlas's brightness curve, which had been declining on a normal gradient as it approached perihelion, spiked. Not a gradual increase driven by solar heating, a discrete jump, sharp at onset and sustained over approximately 18 hours before partially subsiding. The magnitude shift was enough to register clearly across multiple independent feeds, with no corresponding change in solar activity or positional geometry to explain it. And within 48 hours of the brightness spike, the motion data updated. Atlas had deviated from its projected trajectory. The deviation was small in absolute terms but massive in implication. A natural object on a ballistic path does not deviate, it follows gravity. Atlas did not follow gravity. The numbers indicated a lateral acceleration inconsistent with any known outgassing model, solar radiation pressure, or gravitational perturbation from a nearby body. Something had pushed it from the inside. This was the third such event, The previous two had been logged but not widely flagged. The first occurred on July 29th, the second on August 14th. Both showed the same signature, a sudden photometric jump, a corresponding change in trajectory, and a spectral shift in the tail's color index from a reddish slope to near neutral and back again. Researchers within the Atlas Spec Lab had internally labeled these events Delta 5 pulses. The terminology implied what the formal papers were not yet willing to state directly. These were not eruptions, they were pulses, timed, spaced, and repeating with a regularity that outgassing events simply do not produce. The spacing between pulses, roughly 2 weeks each, is not random. 2-week intervals appear in engineering contexts, specifically in duty cycles for systems that require cool-down periods between high-energy outputs. That interpretation is speculative, but the alternative, that a comet nucleus spontaneously generates 3 near-identical thrust events at 2-week intervals with corresponding spectral modulation each time, demands an equally extraordinary explanation. The energy question is where the mainstream position becomes hardest to hold. To produce the observed accelerations, the implied power source inside Atlas would need to output approximately 10 gigawatts continuously during each pulse event. 10 gigawatts is the combined output of roughly 10 large nuclear power plants running simultaneously. No known cometary process, not sublimation, not rotational dynamics, not asymmetric outgassing, comes within orders of magnitude of that figure. The number is not drawn from fringe sources. It follows directly from standard orbital mechanics applied to the observed deviation data. Force equals mass times acceleration. The mass estimate comes from brightness and reflectance models. The acceleration comes from the trajectory update. The math is straightforward. The result is not. Some researchers have proposed that the mass estimate is wrong, that Atlas is far lighter than the reflectance models suggest, and that a lower mass would bring the implied energy output down to something more manageable. That argument has not yet resolved the spectral anomaly or the pulse timing. It addresses one number while leaving the pattern unexplained. The activation event in October added a new dimension that the mass estimate argument cannot touch. When Atlas surged in brightness, the spectral analysis of the coma change character, the CO2 output modulated in sync with the photometric spike. It did not simply increase uniformly the way a heating event would drive it. It shifted in a structured pattern, a sequence of compositional changes within the gas cloud that some researchers have described as a controlled burn profile. Thrust mix modulation is the term now circulating in the private channels of serious researchers who are not yet willing to put their names on the record. The idea is that Atlas is adjusting the composition of what it expels, varying the ratio of gases to control the direction and magnitude of its acceleration. Much the way a thruster system manages propellant mixture to achieve precise maneuvering, natural comets do not do this. The physics of sublimation does not produce structured compositional modulation on 18-hour cycles. Something is managing the output, then there is the tail behavior. Atlas's tail does not stream passively behind it the way a comet tail should. Solar radiation pressure drives comet tails in a predictable anti-solar direction. Atlas's tail shows micro-deflections, small but measurable angular departures from the expected orientation, occurring at intervals that correspond to the acceleration pulses. These deflections are consistent with a body making controlled course corrections, not drifting, correcting. The distinction matters because correction implies a target, a defined path that something inside is working to maintain. The orbital projection that results from these corrections points Atlas toward a perihelion crossing on October 17th at roughly 203 million kilometers from the Sun, placing it in the same solar corridor as C-2025 R2 Swan, which crosses 3 days later at about 150 million kilometers. Both objects in the same narrow region of space, within the same 10-day window, both exhibiting anomalous behavior, both arriving from completely separate sectors of the sky. The corridor geometry is not a casual overlap. It is a convergence. From October 8th to October 18th, the sun's glare makes direct optical observation from the ground impossible. Major observatories issued standard solar conjunction advisories, but internal communications reviewed by independent researchers describe something beyond routine scheduling. Proposals for alternative coverage using radio arrays and space-based assets were submitted and denied. Requests for raw tracking data from facilities with the geometry to observe during the blackout window were delayed without explanation. The result is a 10-day gap, precisely covering the moment when Atlas is most active and most proximate to Swan, during which the official record goes dark. The grassroots network is not going dark. Amateur observers, distributed tracking collectives, and independent researchers are pooling feeds, sharing raw photometry, and building a parallel dataset outside the institutional bottleneck. When Atlas clears the sun's glare, the first updated readings will likely come from someone outside the official system. What those readings will show is the question that matters. Now Atlas has pulsed 3 times. It has deviated from its natural path. It has modulated its own exhaust chemistry. And in October, it surged in a way that nobody predicted and nobody has explained. Something woke up inside 3I Atlas. The instrument logs are unambiguous. The physics demands an answer, and the window when that answer was most visible was the same window when every major telescope on Earth was told to look away.